Hello everyone. I want to start class out today by going over the last two AP problems I assigned. So this one was from Friday. I showed the answer yesterday, and then we'll take a look at the number 18 that I assigned yesterday. All right, so here I just don't have the multiple choice options written up here, but it was E. Let's take a look at what f prime of x is if f of x is equal to sine of e to the negative x. So we have to use the chain rule here. Derivative of sine is cosine of e to the negative x, then times the derivative of e to the negative x, which is e to the negative x, times the derivative of the exponent, which becomes a -1. So kind of cleaning this up a little bit, we could put the negative e to the negative x first times cosine of e to the negative x. All right, so the answer to 18, I'll just indicate right now, is B. If you wish to pause the video, check your answer. If you got it right, wonderful. If not, maybe try it again. I know it might be a little bit tough to see, but it's y equals x plus cosine x is our function here. An equation of the line tangent to the graph of y equals x plus cosine x at the point 0, 1 turns out to be B. So let's go through the process here. First, we need the slope of the tangent line, which is y prime, which turns out to be 1, derivative of x. Derivative of positive cosine x becomes a minus sine x. And then at the point 0, 1, y prime is going to equal 1 minus sine of 0, which is 1. So our slope of our tangent line is 1, and at the point 0, 1, we'll write our equation out here. So we're going to use point slope form, so we get y minus 1 equals our slope, which is 1 times the quantity x minus 0. Distribute our 1, so we'll get x, and we'll add this 1, so that's where we're coming up with that. So hopefully these two problems were no trouble at all. All right, so yesterday we already wrote all this down. I just want to go back over it again so you don't have to recopy it. I introduced you to the mean value theorem. So this again was the hypothesis. It contained two conditions or two parts. And again, that said if y is equal to f of x, and that's a continuous function, it's continuous at every point on the closed interval from a to b, and it also has to be differentiable on the open interval from a to b, because we have to be able to draw on a tangent line, then there is at least one value c in this open interval a to b such that f prime of c is equal to f of b minus f of a all over b minus a. In words, that really means the slope of the tangent line at x equals c is equal to the slope of the secant line that goes through the points a comma f of a and b comma f of b. And here's our little illustration of that. So what I want you guys to think of, what I'm going to have everybody in class do, is take a look at this number 42 off of page 192. I'm going to read it. Actually, let me write it up here again. Okay, so here's the description of the problem. And I want you just to pause the video, think about this. I do have this written out and posted in the solutions with work, but I wanted to really take some time and address this and let you guys get some time to think about this. But it's a marathoner, ran the 26.2 mile New York City Marathon in 2.2 hours. Show that at least twice the marathoner was running exactly 11 miles per hour. So pause the video, give yourself about 5 minutes to really focus more on this problem. Even if you did it last night, or maybe you just kind of looked it over and said you'll come back to it, or maybe you weren't sure what to do. Give yourself about 5 minutes now to really think about this, and I'll give you a hint. We're using the mean value theorem to help us explain this, to help us answer this. Okay, so if you need more time, go ahead and pause the video. If you're just very curious to figure out how we can answer this, then resume playing here. So one thing we can think of, and the only thing we could kind of calculate right now and kind of make sense of, is his average speed throughout the whole race. And we could calculate that by taking the distance and dividing it by the time, right? So we can go ahead and do this now. Because it's the average rate, or his average speed, or average velocity here, that's the same as the slope of the secant. And that is what we first draw in for our illustration for the mean value theorem. So the slope of our secant line would be equal to this average rate of change, or his average speed. And that would be the 26.2 over 2.2, 26.2 miles over 2.2 hours. And that gives us 11.9 miles per hour. Now, we know that he would have to, because this is a closed interval, he would definitely have to, if we have a slope of our secant line, there has to be an instantaneous rate that's going to equal that. That's our slope of our tangent line. So we could start this off by saying, by the mean value theorem, the runner must reach the average speed at least once during the time period allotted, meaning his instantaneous rate of change, his instantaneous velocity would definitely have to equal that 11.5, because the slope of the tangent line would have to equal the slope of the secant line at some point in this open interval. Now, since he definitely has to hit that 11.9 miles per hour, he starts off at 0 miles per hour and ends at 0 miles per hour. So he would have to hit 11 on the way up to this speed and on the way back down. Since the runner starts and ends at 0 miles per hour, the runner attains 11 miles per hour at least twice, once on the way up to 11.9 miles per hour, and then once on the way back down to rest or at 0 miles per hour. But again, with this problem, it was knowing how to use the mean value theorem to help us explain this. All right, I'm going to take any questions at the end. As I've been telling you guys at the end of last week and yesterday as well, please email me if you have any questions whatsoever as I'm going over these homework problems. If there's some problems I haven't gone over that you need to see, please let me know. You could join the Zoom meeting later today. I always encourage that. All right, so we're only going to do one problem in class today, and then I'm just going to give everybody time to just continue working. So this is on page 192, number 19. Here's our function off to the side here. We're given a closed interval. In the book, it gives you the inequality, and it gives you 0.5 instead of 1/2. But here, we're going to let A equal the point A comma f of A, and B is going to equal the point B comma f of B. We're going to write an equation for the secant line AB, connecting endpoints A to B, and then a tangent line. We're going to write an equation of a tangent line to our function in this interval A to B that is parallel to line AB, or line segment AB. So let's start off with A. We want the equation of the secant line, but first we need to find the slope of the secant line. And in that case, remember, that's just the slope formula, f of b, y2 minus y1, f of b minus f of a over b minus a. And in this case, b is going to be the 2, so it's f of 2 minus f of 1/2 all over 2 minus 1/2. Now, if we need to, we could just do the figuring or the calculating off to the side. So if we wanted to calculate f of 2, and we're substituting it into here, we're going to get 2 plus 1/2, which is just 2.5. So this gives us the ordered pair of 2 comma 2.5 or 2 comma 5/2. And then f of 1/2 becomes 1/2 plus 1 over 1/2, which is 2. So this is also 2.5. So we get 1/2 comma 2.5. And if you notice these points, they have the same y values. So when you plot 2 points that have the same y values, what type of a line is that? Should be a horizontal line, but we'll still continue. The pieces should connect here. So we're going to get 2.5 minus 2.5 over 1.5, which is 0. So slope of a line that's 0 means we have a horizontal line, which also happens when our y values are the same. So the slope of our secant line is 0. So our equation should just be y equals 2.5, but we could still use point slope form. So we're just going to use the first point here. So we'll get y minus 2.5 is going to equal 0 times the quantity x minus 2. So y equals 2.5 is our equation of the secant line. All right, now B, we want to find the equation of a tangent line that's parallel to this line. So if we know we have a horizontal line here, we're looking for another horizontal line, or we're looking for our slopes to be the same. So for B, our tangent line, we're going to find that. So remember, f of x is equal to x plus 1 over x. So the slope of our tangent line which is f prime of x, is going to equal 1. Remember, this is x to the negative first, so then this is going to become minus 1 over x squared. And we need this to be 0, so this needs to equal the slope of the secant line, or 0. So we'll set 1 minus 1 over x squared equal to 0, which is 1 is equal to 1 over x squared. So x squared would equal 1, x would equal plus or minus 1. So we may be able to use both of these x values, but remember, we're in the interval from 1/2 to 2, so we only need x to equal 1. So now we need to find f of 1, and that becomes, looking at this right here, 1 plus 1 over 1, so we get 2. So we're looking at the point 1 comma 2, and we have a slope of our tangent line is also 0. So we have another horizontal line, so this should just be the equation y equals 2. All right, so now let's go ahead and check this graphically. So on your calculators, I want you to go ahead and graph the function 1 plus 1 over x. And then I also want you to graph the secant line, y equals 2.5 or y equals 5 halves, and then the tangent line, y equals 2. If you need more time, pause the video again, but let's take a look. Hopefully you're getting this. So we could see this black line here would be the secant line. Notice this is when x is 1/2, and then this is when x is 2. And then right below it, they're both horizontal, so here we have the tangent line, and it's tangent to this curve when x is equal to 1. We could also see down here, we would have a tangent line when x is equal to -1, but that's not in our interval. So these are always ways to check using your calculator. This one would definitely nicer to check on your calculator. We don't want to have to try to worry about graphing that by hand. All right, so not a long lesson today. Like I said, I want to end class for everyone in class with questions. So please let me know if you have any questions whatsoever over page 192 from the last couple of days. Please make sure you look at my solutions with work. Email me if you have any questions. Join the Zoom meeting. Take care, guys. Oh, let me give you today's assignment. Forgot about that. All right, so actually, before I do that, I want to mention, I was getting way far ahead of myself here. I want to give you guys a quiz on sections 4.1 and 4.2. This will be next Tuesday. We don't have class Monday, so this will be next Tuesday, January 19th, just 4 problems where you're going to find the critical numbers or the critical points, find the absolute extrema analytically, and we'll practice this over the next couple days. Find the intervals where f of x is increasing, decreasing, and any local extrema. And then a question just like what we did yesterday, applying the mean value theorem. Show how f of x satisfies a mean value theorem, and then find c that satisfies a conclusion of the mean value theorem. And then here's the assignment. So just some more problems from page 192, another AP problem. Now this is the end of the video. Guys, take care and have a good day.